Okay, hi. So we start this large multimodal model. One of its calls. We generally use more words. There's actually text, is conversation. But because now intelligent machines, robot dogs are slowly getting more and more of these things. Therefore, we generally, this large multimodal model, it is in such applications more and more. So, we specifically introduced how to use Zionet. It's a large multimodal model, one of its inference services. Okay, because we're multimodal. Usually pictures are the main ones. So we need to install an OpenCV first. This is the most commonly used. And then, just to give you a few examples, is that we are actually doing drones. One of the most commonly used autonomous vehicles. Multimodal it one call. Take a look. Because of IONET. In fact, it has several large multimodal models. We're doing better with a relative now. One is called TanGVL. In fact, what we use is to push this 1,000 questions. Tanji 32B. It's such a big model. Of course, we introduced an example in the last lesson. Just introduce. How does he read pictures and speak? Describe what's in the picture. The words of this chapter. In fact, we introduce a more in-depth application. Like the most common, we do this autonomous driving, right? There will be a problem. That is to say, there's a cat in front. It's like being a little car, right? There's a cat in front of you. Where's the cat? I'm going to avoid it. Something like this. Okay, of course. We do this core. Still need to make a prompt word. But this is actually an introduction to Ali's prompt words. Yes, of course it's in Chinese. We translated it. Yes, you can take a look. This is of course mainly in Chinese. But we are equivalent to putting some of his examples are made in English. But the main thing is to say, a visual understanding of something very, very large. Okay, you can take a look. We actually, then, let's take a look at some of his common problems. That's what our embodied intelligence is. It might be useful for object recognition. There's also this targeting. There's also some counting. Of course, yeah. And then there's something like this, which is positioned in 3D. There are also some common functions of OCR. Let's take some examples in turn. Of course, our core is still to write prompt words. Okay, we can all run this and see. Take a look at this. I still used this picture at that time. Let's take a look. 4 drones. Okay, what about last time? We actually asked him to describe what was in the picture. He'll tell you how many drones there are in the picture. A white one, a red one, a black one. There is another model. Okay, he can even tell that this tello is from DJI. And then, of course, we go one step further. We want a location. Is to be able to identify the location of the drone, right? The position in the figure can be marked. We call it B-box. Just draw a frame on it. Okay, frame it. This is what we need. What is this called in picture processing? Target recognition or target localization. Okay, I can only do obstacle avoidance if I draw the frame. Make that robotic arm. Grab it. Okay, the core is this prompt word. This is one of our standard prompts. Good is to identify, right? Locate the position of drone. Then run again. As you can see. Okay, how about this one? It's the next coordinate to the upper left of it, right? Okay, here's its label. It describes. And what about us? In fact, just draw a frame with these coordinates. Circle it. Okay, that's what we do. The whole process of being a robot is actually a very important one. Right? Targeting this? What about the result of the run? In fact, this is the result of our run, right? But this is text. It's a string. We need to remove this quote. Then remove the quotes and then the words. Just load it into a JSON, a dictionary of JSON. Okay then. This is the original picture. Let's draw it first. If there is another one, the picture frame. The simplest. That means tag. Top left and bottom right. And this is the line. This is the length of the thread. Then add one of its labels. And this is what we came up with. Okay, you can take a look. Circle this drone, right? Okay, let's take a look. This is a picture frame. And of course, labels. Take a look at this black one. And this one has white and black borders. Such a state. Of course, this idea. It's a relatively simple little drone. Of course, it's a red one, right? And this is how we most often do this embodied intelligence. The intelligent one is called object recognition. Just locate it in the picture. So what this is an image of a coordinate system. Then it's 0, 0 in the upper left corner. The second word is to count. The most common is to say, how many drones are there? Or let's buy this barbecue. How many strings are there in total? In fact, it is no different from the above call. Just a Q word. Let's take a look. This is our standard template, called locating all drones. Locate all drones. Then output this form. Then say how many. How many? Okay, just a hint. The other keys are exactly the same. Let me show you the output. Take a look at this. It tells you 4 very clearly, right? There are about 4 drones. See something like a drone. And it says, these are what it looks like. It even said that it gave you roughly a few. It's a location. Point. This is usually a central point. Roughly one location. Okay. This is counting. Think about that. If so, if you do this, let's say I count. How much did you spend in total? How many cars are there in a parking lot? In fact, just such a prompt word is enough. If you have done picture processing, picture this. It's an AI that works like this. Can know. What did we want before? Want YOLO. To train a YOLO model. Then it needs to be marked. Now we're just a keyword. You can make all this stuff. And here's us doing the big model and the small model. Its advantages. Right? He doesn't need to be trained. No need to label anything again. Seems like a simple application. Or such an application. Right? We need to label at least a few thousand images. And that's true. It's completely unnecessary now. And he's also relatively accurate. Right? Here's the count. In other words, maybe it's what we use more often. What is it actually? It's an OCR. OCR this is. It's actually marking up the text. Okay, let's take a look. We are. It's actually changing the sentence. Annotate the text in the image. And mark it like this. There are even some text locations. Before. If we have OCR. Requires a dedicated OCR. A small model of it. Right? But there are many, many such small models. Like a Hello OCR. It's a lot, but we use the big models. It can be marked like this directly. It's end to end. I don't need you to train anymore. You don't need anything. You can take a look. Okay, we're using OCR here. With this picture, we have more Chinese here. Some English below. It directly takes this more obvious picture. The text inside is marked. And it's marked with a specific location. You can take a look, right? This one. English. You can take a look. Welcome to Yongxiu University Town. Right? This is an English that everyone knows better. But the Chinese above must be no problem. Of course, there is another one above. It's just a brand. There is no problem. It's a metamorphosis. It can also recognize. Above. These are the ones we use the most. Multimodal application. Right, of course. The previous section gave a description. Look at the picture and speak. Then target the target. Target recognition. Then OCR. Our most commonly used ones. Before. If there is no big model, we may use 3 small models. Need to be marked to do. Now we've done it all with one big model. That's the beauty of the big model. Of course, there are more complex. In fact, it can be marked in 3D. Just a cube. Put a car like this. That's a cube. Mark this car. But this is a bit more complicated. It needs XYZ. And you need its orientation. Built an embodied smart drone. You know that. It has these 3 angles. And it has an XYZ location. He did it too. You can make it. But he does this because he doesn't have in-depth information. It's not LiDAR. He predicted one such orientation. Take a look and then, because of such a large model, we actually put a lot of these small models to work. All replaced. Then in practice, it can be called like this. If you are not sensitive to this speed, but it's a bit slower. If you are not sensitive to speed, this is still very, very easy to use. Like we count one of these. How many cars are parked? It's very simple. It doesn't have to be fast. Maybe every 10 minutes. Very, very simple with large models. But our actual adjustment may have to. Nearly tens of seconds. But what about the small model? Will be much faster, maybe dozens of times a second. Our large model may be every tens of seconds, but he has a lot. Anyway, our computing power it keeps increasing. It may get faster and faster later. What about another one? The key is simplicity. It doesn't take a lot of upfront work. That's what this section says.